welcome to this lesson of our study of vectors. So in this lesson I'll take you through the projection of a vector onto another vector. Okay, so if you have not subscribed to the channel, kindly subscribe to support the channel as well. So let's start. Given two vectors a and b, okay, so have a and b, let the angle between them be theta, then this is how they look like. Also, let's say they are starting from O, okay. Then the question is, what will be the vector projection of, the projection of vector A onto vector B, okay. So let's go to the next slide and look at how the diagram look like, okay. So if I try to draw a straight line from the ending point of A, okay, that is D, this point, to onto the line or straight to the line B, which will cut B at the point C. Okay, it means that it will cut B perpendicularly, meaning it will make an angle of what, 90 degrees. We are saying it's a straight line. So the vector projection of A onto B this time will be the component of A that will be on the horizontal. Okay, so from this side to this side, that will be the, it's like you are finding the components of A on the horizontal and the vertical. And since B is on the horizontal, that will be the vector projection of, the projection of A onto B. I hope you get it. So if I'm to look for the vertical and horizontal component of A, then I have to find the magnitude of A, okay. Alright, so I'll find the magnitude of A, which will be the length of the hypotenuse, which is this side, okay, the length of the hypotenuse. And then we'll find the length of this side, okay. And you find the length of this side. But the length of both sides, the vertical and then the horizontal, will be given by just resolving A into 8 components, okay. So the horizontal part, this side, let me call it that horizontal, so HL, and vertical VT, okay. So it means that if I pick HL, okay, adjacent, okay, so let's pick the theta. Cos of theta will be equal to adjacent, which is the HL over the hypotenuse, which is the magnitude of A. I hope you get it. So it means the HL is the horizontal component of A. That will be the component of A that will lie exactly on B. I hope you get from this diagram. Okay, so it means, let's call this HL something else, something like projection of A onto B, okay, because you are saying that that will be the component of A on B, so projection of A onto B, so that is the length, okay. So that side A onto B over that. So it means that projection of A onto B would now be equal to magnitude of A cos of theta. Now I hope you get this. So this is what you should know. That's the first formula we'll use here, okay. I hope you get this. So now, if you're supposed to find projection of B onto A, rather than that one, you have to change the diagram. That one would have been projection of B onto A will be equal to magnitude of B cos of theta, okay. The same, you pass through the same process, okay. So this is what you have to get. That's B onto A, but here we are dealing with A onto B, so let's stick to one of them, and I hope you'll be able to do the other. But we know that A dot B, okay, A dot B is always equal to magnitude of A, magnitude of B cos theta, okay. Now let's try to find magnitude of A cos theta in one side and see. Now if I keep magnitude of A times cos theta at one side, then it will be equal to A dot B over magnitude of B. But in this context, what is this? This is the projection of A onto B. That is magnitude of A cos theta. So it means that projection of A onto B can also be written as what? A bar dot B bar over magnitude of B. I hope you get this. So in other books, this can be written as A dot B bar over, or B over, let me call it dot B over magnitude of B, and this is the same as A dot A dot B cap, where B cap is a unit vector in the direction of B. Okay, I hope you can see this. This is how we calculated for the unit vector. We said that the unit vector in the direction of any vector is just a vector divided by the magnitude of that same vector. Okay, so since we have that, this can also be written as B cap. Okay, so either this or this formula will work for the projection of A onto another vector B. If it was projection of B onto A, like I told you, this would have been a different case altogether. Okay, so let's pick an example and go through. Find the projection of the vector A, which is given as that, on the vector B, which is that. Okay, so like I said, the projection is simply projection of A onto B. This, we have A here, we have B, that this A, okay, and this is also B. Okay, so it's equal to this is equal to either magnitude of A cos theta when we've been given the angle between them, or this is the same as A dot B over magnitude of B. Okay, so now since we don't have any angle, let's try to find the magnitude of B and A dot B. A dot B here will be equal to what? I will write the answer as well here, and then let you calculate for the A dot B, because we've already passed through A dot, or the dot product of two vectors. So I hope you can do this. That is 10, and the magnitude of B, you know how to also calculate that, and that one too is square root of 6. Okay, then it means that projection of A onto B, which is the same as magnitude of, is the same as A dot B over magnitude of B. And know that A dot B is 10, magnitude of B is square root of 6. Okay, so this will be simply 10 over 6. Okay, over 6 times square root of 6, and that will be 5 over 3 times square root of 6. That is the projection of A onto B. I hope you get this. So this is very simple like that. Let's take another question and see. Given the vector A, which is equal to this 2I minus j, find the projection of vector A onto another vector B if the angle between them is 0 degrees. Okay, so if you remember, we said that the projection is either this projection of A onto B is either magnitude of A by cos theta. Okay, so cos of theta, cos theta, where theta is the angle between them. Now magnitude of A is given in the question as 2I minus j, so magnitude of A will be what? Square root of 3, is it square root of 5 rather, right? And cos of theta, where the angle is what? 0, so cos 0 is 1, so I have square root of 5 times 1, and that will be the projection of A onto B. I hope you get this. So this is very, very simple like that. Okay, all right, thank you, and don't forget to subscribe to my channel, like I always say, so that you can also support the channel as well. Okay, all right, see you.